Okay, so we're going to all we have to do here is name the quadrants that contain the graph, but you still have to have an idea of what the function looks like, right? So you have to have an idea in your head of what the function looks like. It doesn't hurt to make yourself a little sketch if you need to make it make sense in your mind. But the actual absolute value function itself, before the transformation, is in which quadrants? 1 and 2 before that. Just the parent function is the way I should have said. The parent function is in 1 and 2. And then this is going to reflect it in the x-axis, which puts it in which quadrants? 3 and 4. And we name quadrants with Roman numerals, right? So 3 and 4. Okay. All right, so then the second one, the parent function of the reciprocal is in which quadrants? The parent function looks like this, right? Isn't that where the parent function is? Yes? Then we take the absolute value. What's going to happen is that we throw away what's on the left. We reflect what's on the right. Okay? Because we're going to end up with this. Right? Then, so now we have these two purple pieces. Then we have, it's negative, so that's going to be a reflection in what? Purple pieces end up down here. So the green is my final spot, which makes it in quadrants 3 and 4. Everybody okay with that? You see how that works? You do it a piece at a time? Stop me if you have questions or if you disagree. Okay. All right. So then we have this, your square root function. Parent function looks like this, right? When you change the sign on x, what do you get? Reflection across the y, which means this would be in quadrant 2. Then just the cube root of x, that's just a parent function. Should know what that looks like. What quadrants is that? 1 and 3. Is Hannah the only one that knows her parent functions, or is she just the only one talking? Y'all know you know what that looks like, right? Yes? Okay. You can keep talking. Everybody else knows what they are, too. All right. So then this one. Here's another one where we might want to think through it a little bit. Your parent function looks like this, right? Absolute value of x. Okay, so when you change the sign on x, that's a reflection in what? The y-axis. Does it change the way it looks? No. And then I reflect it in the x-axis, so it's pretty much just like number 1. And the answer is 3 and 4. Number 6, is that parent function a square root function? No, it's a what? Semicircle. Okay, so this whole thing in here is just the semicircle part. So all that's really happening is what? A reflection in the x-axis, which gives me that it's in quadrants 3 and 4. Okay. Everybody okay with that? All right. Any questions? Okay, good. So now we're just going to look at what happens to the parent graph point of negative 2, 3 under each transformation. In other words, write the new coordinates and describe the transformation. Okay, so if I'm starting with negative 2, 3, then this happens. What's my new coordinate? Negative 3, 4, right? Because this means I subtract 1 from x and I add 1 to y. We're all good with that? Okay, so that means that I'm going to have a horizontal what? Shift. How much? Left 1. And a vertical shift up 1. Everybody okay with that? All right. This, all I do is change the sign on x, so my new ordered pair is 2, 3. And then that's just a reflection, what? Okay, reflection of, oops, over y-axis. Good. Okay, so on this one, what happens to my x? What do I do to my x? Do I multiply by 1/2? No, I multiply it by 2, the reciprocal, which is 2. Okay, so 2 times the x is going to give me negative 4. What do I do to the y? Multiply it by 2, 1/2. You do what you see. So this would be 3/2 or 1.5 is fine. So this is a horizontal what? Stretch by factor of what? 2. Okay. And then a vertical what? Compression by 1/2. Everybody okay with that? Yes, ma'am. Yes, if this said 2x, then we would multiply it by 1/2. Because whenever you have the x, you always do the opposite. Just like here, we subtracted 1 instead of adding 1. You multiply by 2 instead of multiplying by 1/2. All right, so here, is anything happening to my x value in number 10? Does the x value change? No. X value changes. It stays the same. It changes none. I don't know what I'm trying to say. So then I have 2 changes on y. And when you have 2 changes on y, you do it in what you see in the order of operations, which means I have to multiply before I add. So I'm going to take that 3, multiply it by 2, and get 6, add 5, and that gives me 11. So since I'm dealing with my y here, this is a vertical what? Stretch by 2. And then a vertical shift up 5. Why does this keep getting moved over here? All right, everybody good? So before I start doing anything with number 11, what do I need to do? Factor it out. So this is going to be f of 2 times x plus 2. Now, my y doesn't change on this one, right? Y stays 3. So now I have 2 changes for x. I do them in the order of operations, but I do the opposite of what I see. So this says I'm multiplying by 2, so I actually multiply by 1/2. So negative 2 times 1/2 is a negative 1. And then I subtract 2, which gives me negative 3. Because when you have it by the x, you do the opposite of what you see. So on this little thing here, yeah, it's by 1 over b and not just b. It's the reciprocal. So this is a horizontal compression, right? So I can't spell. Compression by 1/2. Right? And a horizontal shift, which way? Left 2, right? Not 4. You don't go by that number that you see there. That's why you got to factor out and use your new part. Okay, everybody good? All right, and then this is missing this right here. So f of the absolute value of x. What do you think? What's happening here? Does x just becomes positive? Is that all that happens? Okay, so your negative x values become positive, right? Do you have any idea what your new y value is? Whatever the positive one is, right? Okay, so this right here then is going to be, one way you could write it is 2, and then what could I write as my y value since I don't actually have a number to put there? F of positive 2, very good. Does that make sense? I couldn't go plot that point because I don't know what f of positive 2 is. I don't have enough information for that, but that is what's happening, right? So then your x values, or negative x values, become positive. That was a good way to say it, I guess. And then evaluate to find new y. Anybody have, But graphically what's happening, remember, you throw away what's on the left, you take what's on the right, and you reflect it. And that's what's happening, visually. But that's one way to write what's happening there. So that one's a little tricky, but that's what's happening there. I'm going to talk about the absolute value function in just a minute, though, because Jocelyn asked me a question yesterday after school, and I think if I explain it to everybody that way, it might make some of the stuff make a little bit more sense to you. All right, so name two odd parent functions. What's one? F of x equals x, right? Because we can always get away with an easy linear one, right? What's another one? Okay, f of x equals the cube root of x. Could we have used f of x equals x cubed? Yes. Could we have used f of x equals 1 over x? Is that odd? Yes. Okay. There's other options. Anybody want to throw anything else out there? Okay. One-to-one parent function. Both of those work, right? All right. And so, what did you say? You said what? Oh, cubic. Sorry, I'm old, I can't hear. Cubic, which just means f of x equals x cubed. That works. Remember, one-to-one means it's going to pass the horizontal line test and the vertical line test. All right, so which transformation occurs first under this transformation right here? What would I do first? Okay, so I do have to factor that. So I get f of 2 times x minus 3, right? So then when as far as the transformation is concerned, do I use the 2 or the 3 first? The 2. Okay, so that means that I'm changing the x, so this is a horizontal, what? Compression or stretch? Compression by what? 1/2, because it's the opposite of what we see. And by opposite, it's reciprocal. Okay. We all good with that? Yeah, we do x plus 3. And instead of multiplying by 2, you're multiplying by 1/2, or you're dividing by 2. Technically, it's multiplying by 1/2, but dividing by 2 gets you the same thing. We good? All right, domain of the f of x equals the absolute value of x. What's that? What's the domain? It's all real numbers, so it's negative infinity to infinity. And some of you put all real numbers on your domain and range. It's not wrong, and I didn't count it wrong, as long as you used it correctly. But then after, again, talking to the interval notation is the one that is going to be used the most. Do you need to know what all real numbers means? Yes. Do you need to understand the other notation? Yes. But interval notation is kind of the habit you want to get in of using that stuff. And so I'm just going to start to be more consistent with that. Okay. Range of negative 1 over x squared. So that is your inverse square function, right? The parent function looks like this. The negative does what with it? Okay, flips it in the x-axis, so it actually ends up looking like this. So my range then is going to go from negative infinity to what? 0. Do I include the 0? No. Asymptote for log base b of x, and this doesn't even have a number for you to be able to go and like pick actual things, but you do know it has to, that 1 is always going to be there. So it looks something like this, right? So what's the asymptote? X equals 0, because it's a line, so it's x equals 0. And there was a couple of you that got your x equals 0 and y equals 0 mixed up. We should be way past messing that up. Everybody good? All right. So then we want to describe all of the transformations under this right here. So we've got some stuff going on in here, so what do we need to do so we get it right? Factor. So this is going to give me negative 5g times 4 times x, oh, not g times, sorry, g of 4 times x plus 2 and then plus 3. That way I can look at it as what I'm actually doing here. All right, so let's just take care of the x's first. So I would have a horizontal. Now, what is that 4 doing? So that makes that a horizontal what? Compression by what? 1/4. Okay. And then the 2 is a horizontal shift left 2. All right, so we've taken care of the x's, so let's go back out. The negative does what? Reflection in x-axis. In, over, across, it all means the same thing. I know in is weird, but you can reflect something in a line. I say it that way a lot, but it's across or over is the same thing. All right, and then this 5, that's a vertical what? Stretch by 5, because you do what you see. So we've taken care of the negative, the 5, all the x's, so we just have the 3, which is a vertical shift up 3. Okay, then we have an extra line. And the extra line always makes you question everything you ever learned, right? Like, oh God, what am I missing? Are we missing anything? No, sometimes there's extra blanks. But it should make you question it, though, because maybe there isn't an extra blank, right? Like, maybe I am missing something. But once you go back through, just kind of double check that you've got all the pieces. And, yeah, I mean, I did the same thing when I made the key. I was like, what am I missing? And I was pretty sure I wasn't missing anything. We good? Okay. So then we've got this picture here. So it says g of x is what transformation of f of x. So here's my function. So let's just first think about what is f of x. And I probably should have darkened these better, but this x and y axis, they at least have arrows on them so you can tell what's what. What is f of x? Is it a parent function? Yes, it's just what? X squared. Good. Okay. So it says, what is the transformation? So I know that I have moved it over, moved it down, reflected it, and is it stretched or compressed any? Stretched. Is it a horizontal or vertical stretch? Vertical. Okay, so no horizontal stretch or compression? No? Okay. So when we start this off, we know that we are reflecting it in the x-axis, so that's a negative out front. And then it's a vertical stretch by how much? 2, right? So it's a negative 2 times f of, all right, so I'm not going to multiply anything by the x because there's not a horizontal stretch or compression, right? But I did translate it, and we went to the right 3, so that means this is x what? Minus 3, okay? Then we also went down 2, so that makes that minus 2. Okay? Is this squared? Not at this point, right? But you're right, it is f of x equals x squared, but because we're writing this in this notation, g of x, in terms of f of x, since this is f of this, the function could be anything at this point, right? It would be the same transformation, but the function would be different. Then when we go to write the equation, that's when we have to make sure that we use the right parent function. So this is g of x. F of x, the only thing that changes here is the f goes away in what we have here, and this is negative, negative 2, and then x squared is my parent function, but this is going to be x minus 3. Then I have to square it, minus 2. If you type this in the calculator, it graphs it for you. You type this in the calculator, it does not, right? Because this is the transformation notation. So just make sure that you understand the difference between those two, and you can transfer between them. This one right here? It is. It's already there. Is that what you're asking? Oh, shoot. Yes. Thank you. Dang it. Yeah, the second one is g of x, because f of x we already wrote over there, right? Yes, because this is f of x. Thank you. I was rewriting it. It's g of x. Anything else? We're good? Look back over this for your test so that you know how to handle all these things, that you can use the right terms when you're describing it, and that you're doing the right things in the right order. Okay, we're all good? All right, good deal.